All right. So, yeah. Part of it is thinking through the process and making sure, if you tend to have difficulty remembering your trig ratios, there is absolutely nothing wrong with writing this on the top of your page to help you remember and be able to refer to those different ratios that you need. So write that down. Another hint, another suggestion that I will make. For some people, they tend to have a hard time looking at and picking out, like given a particular angle, which side is adjacent, which one side is opposite, which side is hypotenuse. If you tend to have trouble with that, another suggestion is to highlight the hypotenuse, just so that you know that stands out, because that's very easy to pick out very quickly, right? Find your right angle and go across from that and highlight that hypotenuse, just to kind of help you keep track of, okay, that's its own kind of special thing. Then you need to go back and look at the two legs that you have and decide which one is adjacent, which one is opposite, right? So just a little bit of a hint there as well. Yeah. Okay. If you notice, the directions here are just saying find the value of x. So in this case, we're looking for the length of the hypotenuse, and we're supposed to round to the nearest tenth. So we do need to decide which trig function to use here, right? We need to set up a trig ratio and then solve. So given this particular angle, that reference, we know we have hypotenuse. I've already highlighted that. This side is opposite that angle, so I know I've got opposite and I know I've got hypotenuse. So which trig function is that? Sine. There you go. So we need to write this as sine of 32 is equal to 11 over x. Okay. Please be careful if what you are solving for is in the denominator. It's easy to kind of make mistakes with the algebra here. The easiest way of thinking about this really is to kind of set it up, make it look like a proportion, because you're going to multiply, you're going to cross multiply here. So you're going to multiply x times the sine of 32, and that's going to be equal to 1 times 11, or 11. Okay, so then to solve for x, we're going to have to divide by this sine 32. So to get our answer, we're going to do 11 divided by the sine of 32 degrees. And then we're rounding to the nearest tenth. So what do we get for that answer? Sam, what do we get for that answer?
20.8.
Yep, so 20.8. We don't have units listed here. If there were, then make sure you're including those as well, right? Okay. So a couple little things to kind of be thinking about. You've got to be deciding which trig function you're using, and kind of some of the algebraic solving here that you've got to deal with as well to be conscious of, right? Okay. On this one, once again, if we want to highlight, that's hypotenuse. We aren't given any information or asked any information about any of that, but it's helpful just to see that. So we're given this angle as reference. So which trig function do we need to use? Sophia, which trig function should we use, given what we have there?
Is that sine again?
We don't have anything on the hypotenuse, though, so it can't be sine.
Oh, then tangent.
There you go, good. Tangent. So, whoops, and I'm still writing sine. All right, Ireland. We want it to be a sine, don't we? All right, so it's tan of 75 degrees is equal to x over 21. So now the x that we're solving for is in the numerator, which is nice, because then that means in terms of solving what we're going to plug in, we're just doing 21 times the tangent of 75 degrees to get our value. And that gives us 78.4. Okay, check my math on that, please, somebody. Does that sound right? Good, okay. All right, awesome. When we are finding angle measures, Remember when we are finding angle measures, we need to use the inverse trig function. Not the same thing as reciprocals. Inverse trig function. So if we're told that the sine of theta is equal to x, then to get theta, to solve for theta and get theta by itself, the process is that we've got to take the inverse sine. And notice what it's saying over here about how that's written. This is how we write, and we read that as inverse sine of x. So this is saying the sine of theta is equal to x. To get theta by itself, we basically, think about this, guys. We have to undo the fact that this sine is happening to the theta. So that's what the inverse sine does, right? So we're going to inverse sine on the left, and we're going to inverse sine on the right. So theta is going to be equal to the inverse sine of whatever that x value is, right? If it were saying cosine, then theta is going to be equal to the inverse cosine of x. And if it's tangent, then we're going to do the inverse tan, the inverse tangent of x. Yes, you can even do the inverse cosecant of a value, or the inverse secant of a value, or the inverse cotangent. Typically, though, the inverses that you're going to see are your sine and your cosine and your tangent. Okay? Okay, so once again, I'm going to highlight hypotenuse is here, hypotenuse is here. So I'm going to highlight those just to kind of try to help with figuring which side is which. We need to decide which trig ratio we are using if this is our angle of reference. So which trig ratio would we use for that one? Cosine. Yes, CJ. So cosine of theta is equal to adjacent, which is the 18 over 23. So to solve, we are going to do the inverse cosine of 18 divided by 23. So that gets plugged into your calculator. What does that give us? Alex? Oh, sorry, go ahead.
38.5.
Yep, so theta is equal to 38.5 degrees. Okay? Guys, if you don't like that theta, if that gets confusing for you, a lot of people, it gets confusing. You tend to look at it and think it's a 0 and not the angle that we're solving for. So if you want to put an x in there instead of a theta, go right ahead, okay? If you notice, I've put a list up here next to the TV of some other Greek letters that we're going to be using, just so that you're kind of familiar with them. And in any case whatsoever, if the Greek letter is confusing you, then switch it to an x. That's what we're kind of used to solving for, right? Algebraically, that's what we've kind of been searching for all along since, I don't know, probably 6th or 7th grade. We're always searching and solving for x. So if that's easier, if you prefer that, then by all means do that, okay? All right, what trig function are we going to use for number 8? Alex Subin. This is our angle. So you have to think about what sides we're given. We're given hypotenuse, and then we're also given opposite, right? That's across from that angle. So which trig function uses the opposite and hypotenuse?
Cosecant? Or,
Which one's easier to use, though?
sine.
Sine, there you go. So we want to use sine. We could use cosecant, you're right, but that gets a little bit... Okay, so sine of theta is equal to 5 over 21. Alex, if you need to, write that down, right? So you have that as reference. Okay, so that means we're going to do inverse sine of both sides. So inverse sine of that 5 divided by 21. Yuhan, what does that give us? What's the angle measure? 13.8 degrees. Good. Okay, questions on any of that? Because now we're basically extending this to solving the whole triangle. Yeah.
You start with.
Okay, so if you notice what it's saying here is solving a right triangle means to find all side and angle measures that are missing.
Start with that.
Right.
Put the fraction.
Did you get it? You good? Okay. All right. I'm gonna highlight the hypotenuse just to kind of keep that in mind. I am also, on this particular worksheet, if you notice, it's saying side BC. Well, that is equivalent to side A, right? That's this side down here. AB is our hypotenuse. That's equivalent to side C. So for me, I kind of like to think about it that way, and I want to remind you of that as well. So that's why I'm going to write those in as well. You may see it written either way, so it's helpful to kind of think about both ways of dealing with this. If you notice in this particular case, we are given an angle and we are given one leg. And so you got to think about what that means the other parts are that we have to do. We're going to have to figure out the other leg, we're going to have to figure out the hypotenuse, and we have to figure out the other angle. Finding the other angle is really easy. What do we have to do that? Kylie?
72 plus 90, and then you can just do 180 minus 162.
Okay, yep, so 70, so that's one way of thinking about it. Another, if we know the whole triangle has to be 180, and we know the right angle is 90, right? So what does that mean that this angle plus this angle have to be equal to? 90, right? So we could also do, I like what you were saying too. 90 plus 72, get what that's equal to and subtract from 180. The other way is to just think about the fact that these two have to add to 90 and do 90 minus 72. So that gives us, what, 18 degrees. Okay? Here's the deal. When I am solving, when I'm doing right triangle trig, I always only use the information that's given in the original problem. Because if we use an answer that we have figured out, if, God forbid, and hopefully not, but if we've made a math mistake, then that means all of our other answers are going to be wrong. Whereas if we go back to what we were originally given, we can hopefully kind of make some corrections and get some other stuff correct. Okay? So I'm not going to use that 18, even though that's pretty likely to be accurate, but I would rather still stick with that 72 degrees and that 15 that I know. All right, if I want to find side A, and we're using this angle as our reference, which trig function are we going to have to use there? John? Okay, you don't sound too sure about that, but that's right. Okay, yep. So tangent of 72 is going to be equal to A over 15. And so then to solve for A, we're going to multiply by the 15. We're going to do 15 times the tangent of 72. So for A, we get, what do we get? 46.2. So that's side A. And then side C, what trig ratio are we going to use there? Talia? Cosine, okay, because we have adjacent and we're looking for the hypotenuse. Good. So cosine of 72 is equal to 15 over C. Be careful solving for this because that's in the denominator. Think of cross multiplying and then dividing. So C is going to be equal to 15 over cosine of 72, which gives us, how much? 48.5. Check my math, please, guys. Plug in these answers and make sure you're comfortable with how you're plugging in. Okay. Let's set up 14. We won't actually go through the process of solving, but I do want you to get some practice with the SOHCAHTOA. So I'm going to highlight that hypotenuse again. And we are looking at this angle as reference. So we're looking for, well, okay, how are we going to find angle R? What are we going to do for that, Lucy?
You subtract 45 and 34 from 180.
Careful, not 45. What's that right angle?
Oh, sorry, 90.
90, okay. So 180 minus 90 gives us 90, and then 90 minus 34 gives us 56. Good. Okay. Side RT is also equivalent to side S, and ST is equivalent to side R. So we're looking for both legs. So we're given hypotenuse and we're looking for legs. So what's the setup for finding side S, this side here? Which trig ratio will we use? Colby?
Side.
Okay, so sine of 34 is equal to S over 42. And then what about finding side R? Owen?
Cosine.
There you go. Cosine of 34 is equal to R over 42. So in each case, you're doing 42 times that trig function to get your answers. Good. Okay. I want to do one where we're having to find angle measures as well. Let's do 15, looking at what we've got to deal with. Once again, I'm going to highlight that hypotenuse just to kind of help with what we're looking at there. If you notice, we're supposed to find side JL, in other words, side K is another way to label that. How can we find that side? What are we going to do for that? What do you think? We have a leg and we have a hypotenuse. We need to find that other leg.
Could you either way?
What do you mean?
Since you're trying to find the opposite, could you use the adjacent or the hypotenuse?
Oh, but see, we don't have any angle measures, so we can't use trig ratios yet.
Yeah, say it's also.
You can't use the 90.
So we can't use the 90. It's gonna have to be one, either this angle or this angle. But we're just trying to find the side.
Just place your own theta.
Yeah, we're gonna do that. We're gonna have to find these angle measures, right? We're gonna have to find angle K and find angle L. But we're gonna end up rounding those answers, so we don't wanna be, there we go. CJ said that, who else said that? Who was that back there? Vivian. We gotta do Pythagorean theorem for that, to find that other side. That's what we're gonna do first. Then we'll go back and look at those angles, right? And Zach, I'd rather not use, like once I figure out what angle K is, I wanna go back and use just these other numbers again to find angle L. So I'll show you guys what I mean there in just a second. All right, so we need to do 7.6 squared plus K squared equals 8 squared. What do we get when we do that math? Let's see. We get that that side is equal to 2.5 when we round to the nearest tenth. Do me a favor and check my work on that. Okay, if I want to find angle K, and I'm given this side and the hypotenuse, which trig function do I need to use? That looks like a cosine, doesn't it? So cosine of K is 7.6 over 8. And so now to get my angle measure, I'm going to do inverse cosine of 7.6 divided by 8. And so that gives us that this angle is 18.2 degrees. Now, we've rounded here. So that's the other reason why we don't want to use that 18.2. We can use it kind of as a check in a minute, but I want to go back and think of L using this 7.6 and this 8 again. I don't want to use that angle measure. So for this angle, this side is opposite, and then we have a hypotenuse, so that would be a sine of L is equal to 7.6 over 8. Inverse sine of that, and you should get 71.8 when that rounds. Now is when I like to check, right? If these two should add and be really close to 90 degrees. It might not be exact because of the rounding, but more often than not, it's going to be really, really close. So that's how I like to check my work, is to go back and make sure those angles add to 90. Okay. All right. Questions? You're going to do some practice. The homework, the classwork and the homework have to do with solving right triangle trig and asking, looking for some specific sides or angles, but then also solving for the whole triangle. We've got something else we're going to do here first, though. So, but questions on any of this?